Welcome to another episode of the SimTech Podcast, the show where we dive deep into the world of clinical simulation, one conversation at a time. I'm your host, Craig, and today we're exploring something a little different, something that's sparking a real curiosity within the sim world. I'm joined by Ian and Russell to talk about Mirno, what it is, why it's making waves, and how it could shape the way we think about simulation delivery and technician development. Is it a model, a mindset, a movement? Well, that's exactly what we're here to unpack. Whether you've heard whispers about Mirno or this is your first time coming across the term, stick around. This conversation might change the way you see your role in simulation. Hello and welcome to another episode of the SimTech Podcast. Today we're going to be jumping into a supplier showcase and we're going to be talking to a company called Mirno. And to help me to do that, I have Ian and Russell. Ian, would you like to introduce yourself?
Hi, my name's Ian. I'm a co-founder and head of product at the Icelandic startup Mirno.
And Russell, would you like to introduce yourself?
Hi, I'm Russ. I'm a learning technologist here at Oxford Brookes University.
Welcome, guys. Welcome back. Ian, we've brought you back to talk about your company and what you've been doing behind the scenes. Would you like to give yourself a little bit of a brief synopsis of what Mirno is and what they've been doing?
Yes, so thanks. Mirno, we develop virtual patients, and we're using AI to sort of jump on the bandwagon and really superpower what's possible to do. We are a bunch of guys who actually don't have a medical background. We have sort of a patchwork of backgrounds in video games technology and even mission critical simulators like air traffic control. So we are segueing into medical training because we, like many others, there's a huge demand for technology solutions in training in order to sort of fill out the spectrum of medical simulation. And I think what we've learned over the couple of years that we've been doing this is that all simulation is kind of a compromise, and so we're creating our own compromised solution, but that it will really fill in a part of the picture that is already got elements such as mannequin-based training, live sim, moulage, standardized actors, all of the sort of sim toolkit. We know that virtual training has a place, and we think we've got our own sort of novel spin on how we do it.
Where did the idea come from?
It came from early experiments with virtual reality. My co-founder and I, David, we'd actually done a brief stint outside of Iceland, living in the north of England in Newcastle, working on VR really as the initial upswing of the technology in 2013. We were traveling all over the world in the United States, working super closely with Oculus, who were then acquired by Meta, and that's where, of course, all the Meta Quest hardware comes from. We took a hiatus from VR and games to work in air traffic control simulation, and really learning a lot about mission criticality and uptime. And myself, my background is user experience designer, and so it's really about working with people who have a profession and a job and determining how can the software that they need work for them. So we have this background, and we're working on VR for medical simulation because we wanted to bring that. We've done simulation for one elite industry. Let's try to do it for like what we felt was like the most elite in life-saving and care. And I think we really saw the opportunity because there was what seemed to be an underutilization of technology in simulation. But then quickly, like most sim technicians probably already know, we started discovering some of the limitations and compromises that come with virtual reality. So what we identified was that it was what we would call like the characters in the simulation were just really failing to live up to the fidelity and almost really the pace of a real medical team. It's an absolutely incredible thing to watch a really effective team, whether they be doing simulation or working with a live patient, how it's like an orchestra. Their effective communication, their skills. How can we recreate that in VR? And we've never seen it done right in VR, and we actually believed that it was beyond our skills as well. And so our sort of eureka moment was the focus that all of our early users, our early testers had on the patient. And we thought, well, if they're only focused on the patient, maybe that's where our focus should be as well. So we think we can do the patient. And we started having we thought that the technology was there to make a virtual patient that was really, really high quality. And we did our competitor analysis. We were not impressed. We thought that we could see where they made some decisions. We know that a lot of competitors in the market they're really led by doctors, people who understood the problem, but how they went about solving it maybe wasn't the right way. We're kind of coming at it from the other angle. We have no medical background whatsoever, but we do know technology. And so in our team, we have to recruit the medical expertise.
I think you're in good company here. Saying no
Yeah.
medical background, but we know tech. Yes, you're in good company.
Absolutely. And so over the course of the last 2 years, what we've been developing is these AI patients. Originally, we called them virtual patients, but we got to the point where we started to integrate the AI into them to make them live up to the hopes and expectations of the learners. So with that, we really have like a major element is the physiological simulation, or the physiology engine, as we call it. And that's really takes a video game approach versus how others do it. And what I mean by a video game approach is that when we develop a video game, we develop things to recreate realism, like physics and lighting. And you just build these as components that then have a relationship with other components within. And we've taken that approach to physiology. So we can develop a whole component that's all to do with breathing and the things like the amount that the chest should move, the intercostal muscle retractions, belly breathing, if it's maybe a pediatric patient. Then we have to work out what are the interdependencies. So if the respiration rate exceeds a certain amount, the mouth will automatically open because there's just not enough air moving through the nasal cavities.
The lips and stuff go blue.
Exactly. So that's sort of more into the realm of symptoms. And so the symptoms, again, have interdependencies with others, because if we're going to have like face redness, that'll have an effect on paleness, which we have to then look at. Okay, but what's the source? Is it low blood pressure? Is that what's causing that? Is the cyanosis, low blood pressure? Like all of these relationships between physiology are elements that we're simulating. And what's exciting about that is that we're moving away from like the traditional concept of a scenario for training. And we're kind of leaving that behind and saying that we've got a centerpiece, which is really what we call like Maya Creator. Maya stands for Mirno AI Assistant. And it's a tool that allows educators, be them training administrators or physiology lecturers or sim technicians, to create their own patients. So it's kind of like a GPT style interface on one side.
So it's done through like just a prompt. Is that what we're talking?
We start with that, and because that's really like the way to go from like, we want our educators to go from like 0 to 80. So we want to get them most of the way there as quickly as possible. And so that's what we can use AI for. But I think anyone who's used AI knows that it's great at getting you to 80%. But if you ask it to get you to 100, you're going to be disappointed. So once we have the patient and we present a whole series of symptoms, we reveal what are the symptoms that we've adjusted, then we just allow manual manipulation. And I think that that's really key, is that it's the educator that knows what outcome they want. They know what they want to teach. So we're allowing them to modify every symptom to get it exactly the way that they want it before they can
So
exploit
we're almost talking learning objectives here, aren't we?
Yeah, and it's really a psychological change. We're really making the Simtex think about the visual presentation of the patient, because that's what the learners will be faced with in a clinical setting. They're gonna have a patient who has, it's really like a whole picture of different, almost like a narrative of what's this person been through, what's their normal state, what are they like today, do they have comorbidities. How we kind of explain it to people is that mannequins are fantastic tools for doing things to them, but they're not as effective at giving data back to the learners. And so you can maybe see a virtual patient system like ours as almost like maybe stronger in that earlier stage, when it's really about the assessment that the team do. And our, as I mentioned, like all simulation is made of compromises, and where ours starts to sort of not unravel but get weaker is the more that you want to do to the patient. But we do allow interventions. For example, if you were to administer epinephrine, you'd see a really nice spike in the vitals, but also importantly, you'd see visible symptoms. You know, that if you're recovering from anaphylactic shock, you'll see that improvement in real time. So it's quite we think that it's novel, and we're working really closely with people, you know, who this is their day to day, in order to make sure that we remain sort of on the right path.
Russell, how did you come into the picture then? Because you met Ian through LinkedIn, didn't you? How did that come about?
But basically, they reached out and arranged a bit of a demo. And when I saw it, I was like, my initial thought was this fits into a really nice kind of niche, I think, potentially with our children's nursing cohort. Now, with our simulation here, for the most part, if we're doing basic life support or trauma, or something really hands-on, we tend to use mannequins, which, as pointed out, don't necessarily give you so much back. If we're doing something more mental health related, or looking at human interaction, we tend to use actors. So we've got quite a big budget for hiring in actors. But with our children's course, we've got some pediatric mannequins, but obviously you're then limited by the realism of your mannequin, and it is challenging to get real human child actors for a number of reasons: cost, ethics, safeguarding.
I mean, the best you could probably get really is maybe a life cast or something similar.
And that's it, but you still got a mannequin, and with the life cast ones, because they don't blink or breathe, you don't get much back from them. You're still then relying on externals essentially saying, yes, the child is crying. But then I saw this product, and they had an example of a child suffering an anaphylactic reaction. Now, because it was on a 50-inch TV, what you had in front of me was a life-size child who had mottling, had rashes, their lips were blue. And the thing is, with the fact that it's a touch screen, okay, you aren't physically carrying out, say, I don't know, you're not physically injecting adrenaline into their thigh, for example, but there's options for interaction. So there's like a digital stethoscope. You can take that, drag it onto the chest, and you can hear the wheezes throughout the chest. You can physically see their skin changing color and mottling, and you can see that the patient is deteriorating. And the thing also with the patient, on their app, you scan a QR code and it takes you through to kind of their website. And what you end up with is similar to a kind of a SIM pad sort of interface, where the academic, the sim tech, whoever's controlling the mannequin, can then physically on the fly change the parameters to either deteriorate the patient or improve them with the patient acting, with your students' actions. Sorry, is what I meant to say. So actually, you can still then run your full sims and you can base it. But the thing is, certainly with our children's nurses, it gives them a realistic looking patient who is wheezing, reacting to them. You've still got the option to use a digital pen torch to check out pupillary response, for example. And I feel like there's a real niche there. The other really interesting thing is um, with their patient design, their ChatGPT style, you're not limited to, oh, I've got a white Caucasian patient. They've got a whole range of different ethnicities. So actually, say I wanted an Afro-Caribbean child who was suddenly displaying this anaphylactic, you get the chance to see what these rashes would look like on different skin tones. And that's something that is, once again, really challenging. Unless you're using it particularly experienced with makeup, but once again, that's a skilled kind of well, it's a skill, isn't it, in its own right, being able to do that. And this, I feel, just gives you that option just at your fingertips. You can just type, I want a 5-year-old Afro-Caribbean child who's got a fractured arm, and then actually it will show the bruising of the arm and what it looks like. So, I mean, this is where I think there's real potential for this product. That's why I'm kind of really excited about seeing how we can work that into our programs.
Yeah, I mean, it's a really interesting concept, and I've got this thought in the back of my head is when they come into the sim room, the first thing they're going to see is a big 50-inch screen on the bed or something, and it's not until they look down that they see the patient. Isn't that going to break immersion pretty quick? Because they're not seeing this mannequin or this actor; they're seeing a screen. And I've got my lead for simulation in the back of my head saying, look, that there is going to kill immersion straight away. They're almost used to seeing this, even though it's a mannequin. They're used to seeing a person or a person's shell on the bed, not a TV screen. I mean, how are you going to kind of address those challenges?
Certainly with the pediatrics, when you lay the screen so it's horizontal, so it's flat, it looks a little bit like a cot anyway.
Yeah.
And then when actually you're gathered round,
Oh, I see.
it kind
I
of
mean,
gives you that kind of resuscitaire type feeling.
hmm.
Was my impression when I've had a play around with the software, because
So yeah, I
yeah,
mean,
sorry.
what we do is it's basically a level like in a video game, and there is a camera above a full 3D scene, and we just sort of zoom in so that it's the correct approximate size to get a full size person. Where for adult patients, that means you're not going to see below the shins. But so far, we've not had many foot injuries, so we'll solve that problem in the future. But I think I think the most honest answer is that it's pretty good. It's like it's not. It's not some VR 3D, but the most important aspect to us is that we overcame what was killing the VR experience for us, which was that for a team, now we can get the whole team involved. And it's the communication and the collaboration that's happening between team members. That's actually the content of the training. It's not the patient. The patient's actually more like it's almost like the enabler for the simulation that's going to happen. And therefore, by it almost kind of falls into the sort of foreground of the simulation, because what we find is that, as Russell said, the facilitator can be in the space because they're not working that hard to maintain the simulation. They're only maybe queuing the next stage, or a couple taps on a screen every minute or so. It's really very low effort on their side, and we're always automating more parts. But what's great then is that the facilitator, the SimTech, is right up in the faces of the team, and when the simulation is complete, the debrief quality is really high because they could observe minor details, mistakes, errors. We were told that 80% of medical errors are born of communication issues. And so, what are we trying to achieve? Like, we're actually just trying to achieve more effective teamwork. So, yeah, we find that, like, our virtual patients, we just think they're good enough to move on to what matters, which is actually the interaction that the whole team does.
What resolution does it come out at?
It's 4K.
It's 4K. Can it be plugged straight into a camera feed, or does it? What kind of or is it just the screen?
We are not very far ahead with those sorts of monitoring systems that you might get with some of the mannequins, but what we can look forward to is that a system like ours can collect much more data than like a mannequin can, because we're able to really record every interaction that they have with the system. This means that if we're doing like a large scale simulation like we've done in Gothenburg in Sweden, we had 100 student physicians, 100 student nurses working in a 2x2 team. It means that we are able to record like how long did it take for them to move through the ABCD protocols, how, what was the average, what was the median, what was the mean, like, what's the risk, when was the first time that they mentioned the word anaphylaxis, so how long they even began to discuss the correct diagnosis for a given patient. All of that data collection is then going to be far more useful. It'd be really powerful, I think, for some technicians to be able to command all that data and say that we have outliers. We're going to need, on a trauma response, one team was sort of solving within 3 minutes, but another took 7. That's a dangerous difference, and so that's what we're looking to sort of support, is as in addition to recording methods, really the data rich that a more software heavy solution can offer.
How does it deal with things like the communication side then? Is it able to talk back, or?
That's a really exciting avenue for us, and it's something that is just so up in the air. We are doing prototypes just even in the last few days that are massive steps forward for us. Our key thing was it must be real time. It must not have delays. And back about a year ago, when we were still working with VR, the delay from speech to text and then back to speech was around 8 seconds, which is absolutely unusable. That's just a failure. Throw it out, forget about it, not going to happen. We're now down to, if we're using like a sort of a default voice, which is a bit can I swear, a bit less than ideal, those
suboptimal
voices, suboptimal voice, we can do that in absolute real time, and that's so exciting. We would, though, prefer to use a higher quality synthesized voice from the likes of 11 Labs. Those voices are mind-blowing quality, and that may add about 2 seconds in processing through their API, but we can actually cover for those 2 seconds using some tricks, such as making the patient think. If the patient goes, there we go, we covered the 2 seconds. So we can actually pre-record like a precursor and insert that while the API call is going around. It's starting to get technical, but the short answer is we are going to be able to do real-time speech. But we're also hearing from sim technicians in England that it's no use to me to have the most American voice. It's just no use to me.
Yeah, I was going to say 11 Labs. Yeah, it might be a little bit American, or their impressions of what English might be.
I think they're getting so good that we really believe they probably will be the source of a high quality series of voices. Also, it's always expanding, but with 11 Labs, we can synthesize like my voice or Russell's or yours, Craig. And if you give it enough information, there we go. You're now the patient. And so We're extremely excited about this. We're also going further. It's also the lip syncing has to be really high quality, and we want to use our own patients. We're using a lot of video game technology, and the video game lip syncing isn't as it's quite far behind the AI lip syncing, so it's not solved yet, and so we're probably going to get by on something suboptimal, as Russell said, for the remainder of the year. But we're definitely this time next year, this is just going to be solved, and therefore uh, it's just one of those things we're sort of cooking in the background. But we also have a huge amount of international interest, and it's such a hazard. Like yesterday, I had somebody ask me for a doctor asked me for uh, it was Morocco, and she said French, Arabic, and Spanish and English. And we sort of played it off as, yeah, no problem. But we had to look at each other and go, oh, I'm not sure. But ultimately, any language that's like half decently supported in GPT, we can probably work with. So that avenue, that whole aspect is developing really nicely. We would say that a lot of our competitors are actually probably limited by the fact that they have revenue. We don't have that problem. We've made no money.
Well, at least you know where the
So
line is. It really
we're
simplifies
still
things.
fully building, fully developing, and that means that we're not distracted by what is, currently like a revenue source. And so when we say we're a startup, we really mean it.
Well, it's really refreshing having suppliers coming on being so honest and frank, because it's normally you can tell that they're dodging questions or they don't really want to answer. So it's actually nice hearing. It's really, like I say, really refreshing. One thing that I was thinking about is how do they deal with things like practical skills on it? And obviously they can't put a blood pressure cuff on, or they can't put a
Absolutely.
cannula in. How are you getting around them?
So there's two ways that we get around this. One is the occupation of time. When a team is working on a patient, things like applying a blood pressure cuff is we are not going to our system, Cinemedic, which is this digital or virtual hospital bed of the lay flat screen. We're not really going to test technical skills on a screen. It would become a junk skill. It's like you know how to do this. You have other better training to do this part. So what we need to do is ensure that their time is occupied for the correct amount of time, and that means that when we apply a blood pressure cuff, they basically just have to use two hands to press it onto the arm, and then there's a sort of like a quick time event, which is just like a ticking timer, and that replicates the amount of seconds that it takes them to apply the cuff. This just means that they're distracted from the rest of the team. They're not
They're
going to be
taken
able
out
to
of the
do.
game, aren't they?
Yeah,
Their hands are no
exactly.
longer available.
That's it. And so that part can work for some things, but then with other technical skills like an IV insertion into a forearm, it's so long and it's so many steps and it's so technical that we don't even try. We actually have a type of hybrid simulation whereby once they begin the process, the arm of the patient moves off screen, and we bring in a technical task trainer, just the prosthetic arm, and the nursing student or nurse will do the IV insertion on the task trainer. And that way it takes 60 to 90 seconds. They do it correctly with the correct materials. And then when it's complete, the arm moves back onto screen with a virtual IV inserted. So we are basically just avoiding that big weakness because, and we're just utilizing fairly inexpensive task trainers to keep the simulation going because we don't want the wheels to fall off just for such a minor thing. Then with things like the patient monitor sensors, we've recently sort of upgraded so that initially they would just appear on the chest. Now you have to apply them in the correct positions. So we're adding more support. We're able to take temperature from the ear. We've got an improved chin lift and you can check the airway more effectively. But it's just something that's evolving, and at a certain point we have to say, nope, not good enough for touchscreen. We're just going to do something external. We've had some really exciting ideas from people about utilizing video databases of intubation, so that we can apply basically a plastic intubation task trainer to the back of a phone and use the accelerometer to move it around. And once you've successfully inserted that, it's just sort of a checkbox on the facilitator display, and it's just applied. And so there's all these sort of creative and novel ways to get around the limitations of the touchscreen, but the touchscreen actually is a big boost for us. It's a very useful thing, because all the people that we've tested it with, they just get hands-on immediately, and they don't really have any training with it. They just work it out within about 60 seconds.
I was going to say, because some people, especially if you give them like a VR headset or something, they just don't understand the technology. So I mean, if you've been using like tablets or iPads, you understand. Most people intuitively know how to, for instance, zoom in by using the finger movements and stuff. I assume it's that kind of the feel to the TV.
It's all fixed, so you can't zoom or anything. If you want to see closer, you just lean closer. It's high enough resolution, really.
But for instance, if you need to, you said you take the blood pressure, you need to put both fingers on there. So there must be. I mean, how long does it take for like a pre-brief or an instruction before they go in?
It would be about 2 to 5 minutes, depending on the amount of features. Currently, it'd be about 2 minutes. It'll grow to 5. We're supporting more and more, like being able to roll the patient, being able to just do more physical interactions with them. We don't have any user interface. We just think that is an unrealistic thing that gets in the way, or so we keep it to an absolute minimum. There's sometimes things like a visual representation of the pulse, because we can't obviously feel the pulse. So we sort of try to get around the limitations of the technology by doing as little as possible. Because really the pulse is about is it weak, and counting the pulse. And so if you can tell visually through pressing be it the femoral or the wrist, where the assessing the pulse, is it weak and how often is it happening, then we can get around with that. But the briefing currently very, very short, but as we add more and more features, we'll probably be up to about 5 minutes. And we do that with a healthy patient. And then when the simulation starts, it's really like proper problem-based learning, where they've got to come in and just start at the beginning, like, what's your name? What are you here for today? Or if even more exciting, if they're just already unconscious and they're not giving you any of the verbal, that can be quite good too.
Yeah, I mean, the more that you're describing it to me, I mean, you must already be thinking about, what next? What else can we do with this? Because if you've got this basis, for instance, let's look inside the mother's belly, and before you know it, you can almost take the top off and kind of have a little look in. Do you think anything like that's going to be possible?
We are going to steer clear, actually, of things like we don't want to turn Cinemedic into like an anatomical trainer where it's about learning anatomy. We want to keep it like a hyper real trainer, and so it is educators and sim technicians who always bring us the most interesting applications. And one of the applications that we've had to date is things that are quite sensitive. So things like sexual assault initial assessments. Nobody wants to talk to the first time that they talk to a sexual assault victim be a real person. It's much better to rehearse the sensitivity, the consent with a virtual version first. And that was one of those applications potential applications that were brought to us. And another one that was interesting and difficult was domestic abuse on a pediatric patient. We created for Halmstad University in Sweden, Shaken Baby, like a virtual version with Shaken Baby with all of the symptoms like skull deformation, fitting, problems with crying. By doing this, we were able to separate the learners from video material, which was traditionally used, in which this is clearly a real victim. If we can make a virtual version using the video material, we're the last people who have to look at that, and so that. And then the symptoms, once they're actually in our physiology engine, can be manipulated because some patients won't have all of the hallmark symptoms. They might be missing some, and therefore it's an educational objective that you're not always going to get all of the hallmark symptoms. You might have to dig deeper, and you might have to make your diagnosis with some uncertainty.
Is this ever going to be available on a tablet or on your PC or that kind of use, so people can maybe do it in their own time?
It is. It's a sort of a trade-off for us because on a technical level, there's no reason why we cannot do that. The difficulty comes down with things like value proposition. The type of development we do is extremely expensive, but we cannot command like a super high price for an application that appears on an iPad. People just won't go for that. So the full experience is something that we really believe does work best also at human scale. So it is something that we're just experimenting with at this time. We have done it in-house, but that type of training is no longer the sort of full fat teamwork training. It's now maybe a different type of training where it's an alternative to textbooks and video material. You're now looking at virtual patients, and we can do things like multiple choice questionnaires so that people are just learning in their own time. We're looking at offering that type of product to help bridge medical products to the people who have to use them. So it could be things like exotic wound dressings. What's the right type to use for this wound? How do you apply it? What are the steps to prepare this wound? So these are avenues where it's not just the problem-based learning that we've spoken about, but also things that are maybe more day-to-day.
Hardest question of the day then. How much does it cost?
Well, yeah, we're in that stage where pricing discovery is what we're working on. For a unit price of Cinemedic, we're looking at around 60,000 euros with some subscription thereafter for Maya Creator, which is that ability to just keep creating your new patients. However, budgets and how they work with institutions vary, and that means that some institutions can access funds to purchase hardware more than they can for software. And some institutions really need to do the purchase in one go, and we'll just give them a really longer license. So we've learned that we have to be quite flexible with an institution to ensure that we can deliver something really useful to them in a way that allows them to actually buy it.
So Russell, it's coming in at about the same price as a SimMan 3G or any kind of top end simulator these days. Do you think people are going to go for it? Do you think it's worth it?
I think that there's a real chance it'll fulfill a niche. Okay, and as I said before, with simulations, where you need to, when you're building it, you need to think about what's going to be the best product to actually achieve your learning objectives. I think this is just one more kind of option, because I mean, Ian's given some very specific examples, which I think would be very, very difficult to actually achieve using a mannequin.
Yeah, it doesn't matter how good you are at moulage, you can't make things change during the scenario.
No, and that I believe is one of the real benefits of this product. And so I think that's a real option. I mean, and because it runs, as he said, it runs on a Windows PC or it runs on a tablet, for example. I do think there's going to be some options regarding kind of installation as well. But as I said, I think, like I said, I think it depends on your learning objectives. It depends who you're teaching, and it depends whether or not the academic or the person designing the sim genuinely thinks it's going to be the best option for the sim that they're trying to do.
Ian, when can we expect this to be kind of released, or when do you expect it to be, people getting their hands on it?
We were able to deliver Cinemedic as a sort of a pilot experience with a few patient archetypes already. We've already delivered to Gothenburg University, and they've utilized it in their training. For the sort of the full version where the creative capabilities are available with virtual patients, and there's almost this infinite remixability of symptoms and generating patients, we're looking closer to the end of the year. But we're discounting systems until we achieve that. So any institution that wants to work with us on the development can get it for less than the list price.
Yeah, and if they want to get hold of you, Ian, what's the best way of getting hold of you?
So you can find me on LinkedIn, Ian Alexander Shales, and our website is Mirno, mirno.is for Iceland.
Are you providing any kind of demos or anything at this stage for them?
Yeah, we do online demos because we're geographically isolated typically, and it's really easy to set that up with us. But South SimTech Day is a big event for us. We've had incredible sort of support from the guys in Generate. So we'll see about, doing some sort of like maybe a co-exhibiting with them later this year. There's really exciting ideas of manipulating our virtual patients to also include virtual relatives, so that we can use Generate's Bliss system to have these extras in the scene, virtual paramedics, people who are coming and going into the surrounding area, to really make the medical team have to divide and conquer to recreate that sort of organized chaos that is an effective treatment in an emergency room.
Just sounds like we're trying to get rid of people altogether, aren't we? Really, just replacing
the people are the best bits, but we can help challenge them. We feel with the virtual avatars.
Right, guys. Well, brilliant to hear about all your exciting work. Any final comments before we go, Russell?
I'm just, like I said, really excited to be having a chance to have a play around with this product and watch as it develops, because I can think of a number of uses that for the programs that we've already got here. I'm just excited to see how it grows.
Yeah, I think we're just looking forward to getting the boots on the ground in England, and kind of just expecting all the new SimTechs that we'll meet to just tear us a new one and tell us what needs to change. And
exactly.
That's just a lot of fun, and I think we'll take the challenge on.
Yeah, I'd like to say I can already, every time you mention something, ideas are popping into my head. So I suspect you're going to get a lot of great feedback, and maybe a little bit of negative feedback as well, because what you're suggesting is quite a big change to the way people have been doing business for a long time, and people, change is difficult to implement in it. But
I think there's always this expectation that what we're doing is some sort of replacement for what comes before, and it definitely isn't. We really see the value in all the types of simulation that make up that kind of tapestry, and we also believe there's space for our version, our sort of spin on it.
Well, guys, thank you very much for joining me today, and maybe we could look forward to a video podcasting where you can maybe demo some of the stuff that we've been talking to, because it's really difficult to sometimes paint a very visual image with words.
I'll actually hand that over to Russell. He's the one that has our system, not me.
Oh, well, Russell, there you go. You've been volunteered, it sounds like. Yeah. All right, guys, all the best. Thank you very much.
Thank you.
And that's a wrap on this episode of the SimTech podcast. A big thank you to Ian and Russell for breaking down what Mirno is and giving us a glimpse into the thinking behind it. As always, don't forget to follow or subscribe to the podcast so you never miss an episode. And if Mirno got you thinking, share this with one fellow SimTech and keep the conversation going. Until next time, stay sharp, stay curious, and keep simming.